Next topic is structure of BJT. The structure of Power Bjt is different when compared to our normal BJT, that is a normal transistor. So here you will be having one extra layer, so that is known as an n minus layer. So coming to the structure of the Power Bjt, it is a vertical structure. So it is having three regions as per the three terminals, that is an emitter, base and the collector. So we are having the three layer region. So in an emitter region, the emitter, it must be highly doped, whereas the base layer, it must be a smaller in thickness when compared to the emitter and the collector, but it must be lightly doped, more than lightly doped when compared to an emitter, and bit more when compared to the collector. Next, coming to the collector region. Here in the collector region, it is having two regions here in a Power BJT, whereas in a normal BJT the collector region, it was only a single layer, but whereas in a Power BJT the collector region, it is splitted into two regions, that is an n plus and an n minus region. So understand the structure of a BJT, it is slightly different when compared to that of an normal BJT or the normal transistor. So both are having a vertical structure, but the only change is it is present in an collector region, an extra n minus layer it has been added. So the vertical structure, it maximizes the cross-sectional area through which the current in the device is flowing. We all know that a transistor, whether it is a power transistor or the normal transistor, it is having a three terminals and a three layers. The three terminals, it corresponds to a three layers, that is an emitter region, base region and the collector region. So the emitter region or the layer 1, it must be an highly doped, whereas the base region, it is smaller in thickness when compared to the emitter and the collector, and the smaller thickness, coming to the doping level of it, it is slightly doped than an emitter and it is more doped than an collector. So this base, it provides a good amplification performance. Next, coming to the third layer, that is a collector region. The collector region here, it is splitted into two regions, that is an n minus region and an n plus region. So this n minus region, again here it is lightly doped and it is called as an collector drift region. Understand? The collector region, it is splitted into two, that is an n plus and an n minus region. Again this n minus region, it is lightly doped and it is called as a collector drift region. Coming to the thickness of the n minus layer, the thickness of an n minus layer, it determines the breakdown voltage capability of the transistor. The n plus region, again it is highly doped. The n plus region, it serves as a collector contact for external circuit, means it is connected to a terminal part. Let's understand the diagram, then we can understand how the doping has been done here. So in order to understand the diagram, so first part is, this is a vertical structure. So first I am going to draw for NPN transistor. Next I will draw for PNP transistor. So this here, this part, it forms an N plus. This part forms the P, and the collector part, finally it is splitted into N minus and N plus. So this, as I told, it is an NPN transistor. First I will draw, I have told. So this is an NPN transistor. Now we have to add the terminals for it. So this is an N layer. It forms an emitter. Next P layer. Here it forms B, base. Next, as I told, the N layer of the collector, it is splitted into N minus and an N plus, and this portion it forms the collector. So coming to the doping concentration levels of this N plus layer, it is the doping concentration is 10 power 19 per cm cube. P layer it is 10 power 16 per cm cube. N minus layer it is 10 power 14 per cm cube, and N plus layer it is 10 power 19 per cm cube. So this is a doping concentration levels. Now as I told, this N minus and an N plus, this complete forms the collector part. This P type, it complete forms the base part, and this N plus, it completely forms the emitter part. So this N minus layer, as I told, it is a lightly doped region and it is called as a collector drift region. Whereas an N plus junction or N plus region, it is an highly doped region and it forms a collector contact for an external circuitry. So this to an N plus layer itself, we have connected the terminals with the metal contacts. So N plus region, it is used for a collector terminal connection for external circuitry. So this forms an NPN transistor. The same way we have to write it for PNP transistor. So remember PNP, we have the first layer is P layer. So the P layer, it must be an emitter layer. So this is a P layer. So P layer, the terminal we have here, it is an emitter terminal. Next is an N layer. To an N layer, we must have the base terminal. Next, the collector region, it is splitted into two here, that is P plus and P minus. So first I'll write P minus and next I'll write P plus. So simple. So this is an PNP transistor. In a PNP transistor, the first layer is a P layer that must be connected to an emitter. Next layer, it is an N layer that must be connected to the base. And this part forms the collector part, where in a collector, we are splitting it to two regions. One is a P minus layer and other is a P plus layer. So this P plus layer, it is used for external terminal contact as a collector to an external circuitry. Now let's see the doping concentration. It is same as that of an NPN transistor, that is the P layer doping concentration, it is 10 power 19 per cm cube. N layer concentration is 10 power 16 per cm cube. P minus layer is 10 power 14 per cm cube. And P plus layer, it is 10 power 19 per cm cube. So this forms an PNP transistor. So this is a structure diagram of an NPN and a PNP transistor. So I'll just quickly revise this structure diagram. So as I told, the structure of a Power Bjt, it is slightly different from an normal Bjt, even though both are having the vertical structure. The difference here, it is in a collector region, where in a collector region it is splitted into two regions, that is N minus and then N plus regions. So emitter region, it is highly doped. The base region, it is lightly doped when compared to an emitter, but more than to an collector, and the thickness of it is very small when compared to the emitter and the base, and it is used for amplification purpose. Next, collector region, it is we are splitting into two regions, that is an N plus and an N minus regions, whereas N minus region, it is a lightly doped region, and it is called as an collector drift region, whereas an N plus region, it is a highly doped region and it is used as an external contact. Now these are the two structures of an NPN and a PNP transistor, where you can see that these red color, what I have marked here, it indicates the concentration levels of each of the layer. So as I told, this is an NPN, indicates an N layer must be connected to the emitter, P layer to the base, and the collector part, it is splitted into two, that is N minus and an N plus layer. The same way here in a PNP transistor, so the collector part, it is splitted into two layers, that is P minus and P plus layer.